Welcome to the Future of Work Live. Hosted by Mark Salisbury, author of the new book, Socrates Digital for Learning and Problem Solving. Each 25-minute episode with Mark and his guests prepares you for the upcoming new world of work.
Well, welcome everyone to the Future of Work Live. I'm Mark Salisbury, your host. Today, our guest is going to be Scott Moody, computer scientist and software architect. And I've been emailing with Scott as we've been coming on, and he's having some connectivity issues. Can you imagine that? In the 21st century, we still have connectivity issues. So let me tell you a little bit about Scott, as hopefully he is on his way. And Scott Moody is a computer scientist with an MS and a BS from the early days of University of Washington's Computer Science Department. His main interests are in elegant language and compiler design across distributed systems. He spent 31 years at Boeing in research and development, earning the Associate Technical Fellow. He has been a 15-year contributor to ACM Computing Reviews and continues research and teaching through his own company called Kona Currents. So that is Scott, and I'm still looking for him to come up in my left pane here. So as always, you always have to think about, well, what can you do if one of your guests doesn't show up? And I think, well, I could talk about something I know about. And so I'm going to chat a little bit about my upcoming book. It wasn't planned for this time space, but it is called Socrates Digital. And I'm going to go ahead and see if I can share my screen just a little bit here. I'm going to make it the live one here. And that's not something we normally do. So we'll go ahead and I will be able to share this screen with you. And there is my upcoming book, you can see. And if you just type in Socrates Digital, it will come up. And so I don't expect it's going to be a bestseller on the New York Times bestsellers list because it's basically a computer science text. And it isn't a regular one for like undergraduate studies. It's for like graduate students and researchers to be able to look at this new paradigm of having a computer program really interact with you like Socrates would, help you solve problems that are really the best way for human beings to solve problems. And so that's the idea behind Socrates Digital. And it's because it's for human beings. See, the deal is we have lots of AI algorithms. I've worked on some during my career, and we have lots of AI algorithms, but I see Scott's coming in. What perfect timing. We have lots of AI algorithms out there that we can't understand, right? So, but we can't understand the things Socrates talked about 2,500 years ago. And that's what the book is about. And we'll have an episode on it later. But between now and then, we're going to get back to Scott Moody.
I'm on. Am I on?
Yes, you are. And boy, am I glad to see you.
I bet. Thanks.
Yeah, this is great. But you know what? It gave me a chance, Scott, to give them a plug for my new book. Oh. And I also introduced you. I told them about the 2 guys you raised from the dead and the 30 guys you healed. So I gave them your bio so they know all about you. So let's just jump right into this because we know that you know a lot about technical things here. What is the Internet of Things?
Yeah, so like you say, Mark, I mean, we worked together a long time ago and everything, and the things we did in the 80s with remote messages and things like that, we were connecting all kinds of stuff, right? And now today, there's newer devices. There's, we got the smart everything, right? We got the little teeny devices that are Bluetooth. We have actually the newest thing, these ESP 32 chips, which big short world where there's a hard part, getting chips. So these things are like $10, and they have Bluetooth, they have Wi-Fi. You go into your cafe or whatever, you supposedly have smart this, that, and the other thing. So the Internet of Things the term came out to try to connect all these devices in some fashion. And it's been a challenge both by connectivity and by the power of all these devices. Everything needs a battery, right? And the batteries only last so long. And how are we going to, especially when they're embedded in a device, you can't get the battery out or whatever, so the battery issues, the power is going to be an issue, a big deal. But I'm hoping that by connecting, being able to turn my coffee on in the morning as an, simple example of the Internet of Things is going to be really cool. And they're talking about billions of devices at some point in time, and how we're going to work that.
Oh, wow. It strikes me that this has the potential to really change our work landscape, just the way that we would work. And it seems like it would be just unlimited amount of information you could have like at your fingertips. And so I'm going to go to the next thing that we would really like to ask you today. And that is, how can we make these Internet of Things applications for the workplace then? How would we go about doing that?
Right. And at one point, I mentioned Bluetooth is a big one where we can connect devices within within a couple hundred feet kind of thing. And I've been looking at how to bridge that to further away, so I can be here and talking to my, feeding my dog 100 miles away, while watching a camera or whatever. But how we're going to build these things is we need networking mechanisms. And there's coming out with some really new things. This technology called MQTT is an example of a communication, a publish subscribe, that we can talk between the small device and our edge systems or our other systems. And so networking, we need some back end processing in the cloud or wherever you want to put it that does smarts at some level. I mentioned the Bluetooth devices, but then we need to be able to develop code in our apps, and the iPhone, for example, and Android, and everybody has connectivity to these devices. So we have some really cool technologies, and then we how to scale that. That's what you need to think about next. I can talk about that.
Yeah, well, I know you've been working on how do you bring these together? What's the architecture? Because I think that's where the magic is. Now we've got so much stuff out there. How could you bring this together in like a dashboard that people could just, be able to pull up what they need, when they need it, and that kind of thing. So maybe you could talk a little bit about how enterprises, companies could build one of these things using these ideas that you've been coming up with.
Right. So like I mentioned, these back-end processors, actually a really cool system called Node-RED that came out of IBM, node-red.org, really powerful back-end web front end that you program visually. And so when a message comes through that says, hey, it came from the the sensor for the coffee and it comes through the network, you can have code in there that does stuff and routes it to the right people. So we need routing mechanisms and things like that. But I mentioned the iPhone. I've been developing a lot of apps on the iPhone, iPad, Apple TV. There's all kinds of really cool display mechanisms that we can interface to these devices. So that's really exciting, what's available there.
Okay. And I know one of the things I'm going to go to my next little question here. Can you give us an example of a really cool Internet of Things application? Because I know you have a really cool example.
Yeah, well, one of them, I actually been working with a company. This is where's the picture? Pet Tutor. They're out of Indianapolis, actually, and they put, we talk about these little chips. They've got one of these chips in here, and so this thing, which is a really quiet feeder, which is a trick for these, for the technologies. So they have a feeder that's Bluetooth enabled. And so they created a little remote control, obviously, and maybe an RF version, but they had a Bluetooth version and they could talk to it. They can only talk from the device where, still 100 feet away, and, which for animal training is actually valuable because you're not scaring the animal, let's say. But I went and took it further and tried to route the data as far as I want to go through other technology out past the Bluetooth, through the sockets, through the internet, through wherever, and back to the iPhone in another location. So when I developed a thing I call iDog Watch. Watch. It comes with a camera. It comes with these smart little beacons. It has an iPhone app, things like that, that it's really fun. And I have Apple TV. I can feed my dog from my Apple TV or anywhere, things like that. It's really, really fun to build. And it's a great test bed for these ideas. When I was teaching at Renton Technical College in part of my computer science class, I kind of teach on my own as well, to Boeing and everybody. But the ability to use something like that that's well defined, and then maybe you want something else. Like we had students doing soil sensors and for your garden, uh, and things like that. So it's really cool what you can do with these sensors, with these iPhone apps or whatever. Really powerful.
Well, one of the things that strikes me, Scott, is we think we've got privacy issues now. I mean, it just seems like, wow, this is going to just open it up. I mean, I can just see me at my desk spying on my colleague at work, Bob, and seeing what he's working on, right? And so it just seems to me like this would just be a Pandora's box for privacy. So is that kind of a thing that you've been looking at too?
Yeah, we've been looking at that. That I think in some ways it's overblown because heck, I can barely connect to these things. I have a hard time getting on the internet right now, right? Uh, so, and the protocols, at least the Bluetooth devices and stuff, once they connect, one guy gets to connect, and you can have passwords and all that. No one else even connects. Even to save battery, they stopped advertising once they're connected. Things like that. So there is a lot of things built into the protocols to help that security or safety. These networking protocols, they all have the ability to have passwords and things like passwords, as well as hidden name. How to hack up. I don't even know how to hack passwords. When I make up pretty interesting when you have to do that. But
Yeah,
the
yeah.
the, the naming of things. So, and actually naming is a big deal in what I teach as well. Is we got to name everything. We have to have ways of getting at the right one, right? So if we have my smart
Yeah.
house, it has every single light bulb with an on-off switch, right? Uh, how the heck we get a name? In my kitchen, I have four or five light switches for lights. They don't have a number. They don't have a name for that, right? You go up and see
Yeah.
them. So naming is a really complex problem. It actually helps security as well, if we want to go back to that.
Yeah,
Uh,
yeah. Well, let's skip over to what innovative technologies do you see, right, out of all the stuff that's emerging that will really soon affect the workplace?
I think just with the workplace, everyone's going remote, right? So there's a
Yeah,
whole new ball of wax of some sort there. No one wants to seem to go back to work. I mean, I've been retired and working at home, so it's pretty nice that everyone else wants to do something like that. And
yeah,
I, but so what is the workplace? But I mentioned the issue with the batteries in these devices, and if we start putting these everywhere, we're going to have a bigger issue. Here's the coolest thing I've seen. I don't know if you can see it. It's actually it's
yeah.
a plus. It's a light bulb or on-off switch. Well, it turns out there's a group out there that are working on this thing called energy harvesting. And the University of Washington Computer Science has an energy harvesting group as well. This thing requires no batteries. It requires no power. It creates the power by clicking on the button. And by clicking on the button, it creates enough power to send a message at a real low bandwidth, whatever
Wow.
it is. Uh, and it's not Bluetooth. It's nothing. It's an RF like frequency. I actually never have connected it myself, but they're putting these in buildings all over the place, because once you do figure out how to know, that this light switch goes to light bulb number one versus number the living room light bulb versus the kitchen light bulb. Um, Once we get that working, we don't want wires everywhere, and we don't want Bluetooth with the battery issues unless they're all connected to power. So you get rid of the cable and you put the cable back because you need the power. Uh, so that's a neat the energy harvesting. I haven't seen a lot of people looking at that per se. Like I said, but the other one is the computer vision. Well, first off, the power of all these processors we're getting on the iPhone, the new MacBooks with unbelievable power, and everybody else. what are we going to do with all that processing power? I'm most excited recently about the computer vision, that the machine learning ML, Google ML and Apple ML both have some really powerful open source. Actually, Google's all open source,
Yeah.
and they can recognize objects, some with relatively good confidence and some with really lousy confidence. But uh, well, and so being able to see things in the future and being able to recognize what they are, and doing things with that, I think that's really powerful.
Well, it also strikes me that one of the things we saw with personal computing is you got the mainframe on your own desk, right? And then this is kind of like, I think people will have to really, and I think that's what our audience might be thinking about today, is that they need to think about how they're going to gather the data they're going to need, right? The information they're going to need. And there's lots of new ways to gather that information, right? And so this could be a kind of, when we go to the workplace, is it's not only what you know, but it's all the sources that you can tap. And this is a new kind of technology and frontier that's going to help people configure their own information environments, I would guess.
Yeah, we are working on essentially affinity groups, which is one way to scale a lot of this problem. So back to the workplace, we have common work, conceivably being happening in the same area, right? The same workplace, unless you're off, surfing the web or whatever. But in general, messages come in, so you don't need to be subscribing, let's say, to every nugget of information. Upstream can be subscribing and you getting the data because it's related to your work. So
Yeah.
there's these content addressable, content routing networks, which are different than the connect, to the topic. We had this issue where I had an office at Boeing over in Seattle and over in Bellevue. So they had an email address that had both those. You had to have two different groups, one for the Bellevue group, one for the Seattle. And so then if you were mobile, you had to have two messages because you don't know where you are, right? So that's the problem with that, is that people haven't been able to get past that. And essentially, I mean, we keep thinking about everything's location based, but we're usually a one of, yeah, you can
Yeah.
connect to me because you can find me, but I don't know who I should be connecting to. I mentioned when we talked before, I worked on this thing called the Future Combat System, where the idea was to get smarter devices and things like that. And we had the issue where you got everybody with the smart iPhones and whatnot that knows when the missile or the bullets fly, because they have smart devices that sense the missile or the tank or whatever shooting at you. And so you're all, you got the platoon A guys, because A was planned to be in foxhole number one. All of a sudden this platoon B guy jumps in your foxhole, and he's got the exact same technology, but he's getting none of the same messages because he wasn't supposed to do that.
Yeah.
How do we adapt to something more? And back to the workplace, same idea. How can we leverage all these sensors and things like that?
Yeah. Yeah. Well, I'm going to shift gears right now and go back in time with you. And so, can you describe how we tried to implement the max headroom vision? I know our audience is, because we had a little chatter about this in LinkedIn,
All right.
and I know people saw the words. So, what's it about?
So Max Headroom, actually, I just found this. It wasn't available for long. It was 1986, I think it came out, and there was a big, the Coke ad or whatever. But the title here, it says 20 minutes into the future. That was the whole thing. They had vision in '86, and they had computer graphics, that they connected to the TV, to the making films and things like that. But they kept thinking about something in the future. And so we took that in our work, right? With we had, Mark, you had the voice, talk and draw and all that kind of cool stuff, where
Yeah, yeah,
we could, that's still a thing that I think is not being done, is the voice recognition. I'm not a fan of voice recognition at all. It doesn't work with a hoot for me, and it's not exact enough. And we talked about computer vision, but so how do the Max Headroom? They had, all kinds of really cool ideas in the future, and then from there we went to, Xerox PARC, for example, was one of my heroes of technologies out there.
yeah,
The cone
yeah,
trees. Remember the complexity of seeing things in 3D. How are we going to start seeing stuff and seeing things we don't see that are hidden in the air?
yeah,
So the complexities, and now with 21st century, the amount of information and is just out the door, of complexity. So how are we going to manage that? And then Max Headroom was they had some cool ideas on that. The first episode was all about, we have too many channels right on our TV, and as soon as there's an ad on the channel, you would switch channel. You would go to another one because we have an 18-second attention span, basically, from Scott Adams, and I used to listen to him a lot. But 18-second attention span. You've been there teaching your classes, right? And you try to get somebody looking at you during the class is really hard. Unless you're really,
Try online, for example. Yeah.
Yeah. So Max, just a neat vision of what that. I'll have to send you this. Maybe you can watch it again, but it's pretty fun. But I think the futuristic ideas are there now with, God, the amount of code you can develop in these iPhones. I'd mentioned all the networking. There's another really cool thing called the CocoaPods. It's a reuse library that's on the web or local or wherever, and it's a really neat way to package up chunks of code that you just grab in one line of code that is all absorbed. So there's some things that are coming to fruition that we've been dreaming about for years, and we'll see if
since the Max Headroom days.
Yeah,
hey,
pretty much.
I want to make sure we have time to talk a little bit about this. What I understand is you've developed and you also teach a software architecture class. And so what can you tell our folks out there who might be interested in that?
Sure. Well, actually, at the end of my Boeing career, I started coming up with, how to formulate a lot of this stuff that I learned in Boeing, and we are always in research and development, so we were always thinking of really cool stuff as much as we could. So I came up with a class. Actually, I call it the Adventures of Knowledge Shark. I'm trying to put this into my textbook, but it has all the kind of the whole software architecture aspects of how we're going to identify the problems and how to relate them to previous problems that we've talked about, and half of them go back to the work we were doing in the 80s or whatever. But I mentioned things like the Napoleon telegraph system. People didn't realize 1800, 1799, Napoleon had people build these towers throughout Europe, and then the English jumped in. Everybody wanted a tower that was a big honking thing like a windmill that had they could relate an ASCII character essentially and ship it across Europe. So it was an internet packet, and this before the next version of the telegraph, which we've heard of, which is the electrical telegraph, right? So things like, but being able to talk about all these really cool computer science problems. I think computer science is still the coolest, most precise thing we got going for us. Even though we can do anything right with it, we can also do stuff, the right stuff. I wake up every morning and thinking, 100 years ago, I wake up and I'm in my farm and I could, milk the cow and do a 5, 6 things. But now I wake up and I got an infinite number of things I could do with our technology. It's so cool. In my class, I try to describe all, what's available, and we kick the tires on these Bluetooth devices and stuff like that.
Well, let's go right to our takeaway here. And all this comes together. And so what I have for our takeaway here is the Internet of Things is here. And but it will take some integration with enterprise systems to really leverage it in the workplace. And so what would you tell our users, or I should say our viewers out there who are in the workplace, how they can think about using this technology?
Yeah, I think that being able to kick the tires is so easily now that we used to, develop, you compile for a day and you could test something. Now we can test things so quickly. There's all these capabilities, that I talk about or other people talk about with the Internet of Things. Is just a really good example to kind of get it into your simplicity that we can start playing with, and then just think about, if you talk about the workplace, what kind of things you want to make easier. Truly, it's that level, back to turning the coffee on at night, which my thing broke. I can't do that anymore. But feed the dog remotely. What else can I do? I mentioned the soil. You can test if it's got enough moisture in your garden, things like that.
Yeah.
Really cool. What's available, and a lot of it was tinkering at one point. Now we can hook it up to our real systems. We can have the Apple TV interface to it, for example.
Very cool. And it's good to see Scott still working on cool stuff. It's been a few years, but I see the passion still there. So I want to thank you for being on our show today. And I want to remind our viewers that they can catch us next week. Our next episode is Wednesday at 1 p.m. Central Time. It's always Wednesday at 1 p.m. Central Time. And we'll look forward to seeing you then. And thanks a lot, Scott, for coming in and chatting with us today. And boy, am I glad you made it.
Yeah, that was bizarre. Yeah. I tried everything. I just got a new satellite on my house too, so I was hoping for that would work.
Thanks for coming. Thanks for coming.
Yeah.
You can find the Future of Work Live episodes in video and podcast format on www.marksalisbury.com. Additionally, YouTube hosts the video episodes on the Future of Work channel, and Apple, Spotify, and Google host the podcasts.